Hello and welcome to another tutorial. So this time we are going to be continuing to add to the character controller. So what we're going to be looking at adding this time is having the surfaces that we're on be able to have effects. So this isn't something we'd use necessarily on every surface, but it allows us to do things like what we saw in Portal 2, where you could have something that increases the run speed or other effects. So we're going to set up a bit of a generic approach for handling that. So let's dive right on in. First thing we're going to need to do is we're going to need some areas where we have different surfaces. So what I'm going to set up is, because we want this to be able to apply to kind of anything, and we'll set up a bit of a system where there'll be a script on the objects that are having this effect. So we can, because the character is already having to do a lot of raycasting, we can just bootstrap off of that to work out what we're actually standing on. So what I'm going to do is I'm going to add in just some cubes, and we'll move these all the way down. We'll line these up so that they're pretty much lined up with the surfaces that we've got here. So what I'm going to do is we'll make this one, we'll increase its length. Let's go for 15. And I'll increase its width as well, make this a little bit easier to work with. Again, line it up. I'll make that more like 25. That's pretty good. So this will be one of the ones that we'll have. So this will be surface. And we might make it that this one, what it does is it's a speed increase. And then right next to it, I'm going to set up one that it will be speed decrease. So that will be the increase and decrease ones. And just to make it clear what's sort of happening, I'm going to create a couple of materials for these just to make it a little bit clearer. Speed increase and a speed decrease. So decrease and the increase one. So decrease, I'll make it look a little bit sort of like an icy color. And then the increase one will make that look a bit of a lighter sort of color like that. So, okay, what I want to then do is, we've got different components here for the character motor. I'm going to add in a surface effect folder. And I'm going to set up a script. So this will be a surface. This is going to be a surface that can cause effects. So naming of things is always important. So the effect is going to be the actual particular thing it does, but the surface effect is the source of those effects. So I might call this, it's always tricky naming these, surface. Let's call this an affectable surface. Actually, no, that's a terrible name because that implies that the surface is being affected. I'm going to go for surface effect source as the name for this. So the idea is going to be the script will be on each of the things, and that will be able to drive the particular effects that can happen. So we're going to put that on both of these. So that's good. Now the player, we want to make sure we check the sort of layers that the player is actually checking, because the player is already doing a bunch of recasts, so it's checking default and water. These are in the default layer, so those would get picked up. So that's good. I'll move the player a little bit over this way so that we're a little bit closer for being able to test these. So then, okay, we've got the surface there. I want to make it that these are a little bit generic in terms of how these work. So I want to be able to have multiple different effects. And I think the way I want to set this up is that each effect source has a stack of essentially operators that it could apply. So what I'm going to do is I'm going to create an effect operator. And this is going to define the particular type of effect that is actually happening. So in terms of how the effects work for this, I want it to be fairly generic. I want to be able to have the surface there and link it up to a particular set of data. So I want a scriptable object for that. So that's what I want to do. So I'm going to create an effect set. So this will be the scriptable object. And that will define the particular type of effect that it has. So we'll set this up where what we'll configure is, so a couple of things I want to be able to configure with this. One of the things is I want to be able to configure what this applies to. So if I map out the kind of things I want to be able to set here, I want to be able to control what it changes. I want to be able to control how it changes it. So in terms of what it changes, that's things like speed, etc. In terms of how it changes it, that might be scale, it might be offset, it might be setting. So there's different behaviors there. I want to be able to change how much it changes by, and I want to be able to stack multiple of these. So stack multiple. So, okay, as soon as I'm stacking multiple, that means I need a list. As soon as I've got things like this, that means I'm probably looking at something like an enumeration, probably a couple of enumerations actually. So this is going to change to a scriptable object. I'm going to set up a public enum, and this is going to be affectable parameter. And so we know speed is definitely going to be one of those. So I'm going to have speed. And I'm going to set this to specific value because we might want to have specific value ranges there. So I'm going to actually set that to, we'll have a unknown, just so we've got basically a foul case. And then so we'll have speed is going to be 1. This way we might have lots of different ones. We can lock in the values now. If we had some that are for a character, some that are for something else, we could use different number ranges for it. That can work quite nicely. So, okay, we've got that. We're going to have an effect type. So, okay, that would be able to be things like scale, offset, set. So scale, we could do increasing and decreasing it by a multiplier or divisor. Offset would allow us to add and subtract to it, and then set will just directly override it. So that looks good. And then the amount that it changes by is straightforward. So, okay, so far so good. What I would then also do is I would have in here, I'm going to need to have a system serializable, and we're going to have a class, and this is going to be an effect set entry. And then what we have is this will have the parameter. It will have our type. So type, and it will have a value. So then we can have here a serialized field with a list of our effects. So that this one effect set could change multiple parameters, we could group them, you could chain stuff together in different ways, so that is going to work quite well. This, we need our create asset menu, give it our menu name. So we already have, I believe, for the character motor, a section, so we'll just put these under the same area. So just for consistency. And so that will be effect set. And then we can set the file name to effect set. So that's good. That'll allow us to have that set of effects. I then can adjust this surface effect source. So it is going to have our effect set, linked effects. And now we can configure which effect set is going to be applicable for these different ones. I can get here and I can create an effect set. So I'll have speed increase. And we'll also have a speed decrease. Then I just link these up to it. So we could have different ones. So this makes it easy if you've got different types of speed increase ones or decrease ones. Makes it that it's all nicely grouped. You can easily go and modify it in the one place. And then in terms of the effects, well, we want to add in, it's going to change speed. It's going to scale it by 1.5 for the increase. So, sorry, that's actually the decrease. So we scale it by 0.5. Whereas the increase one, we're going to go speed, scale by 2. So we have something that will decrease the speed and something that will increase the speed. So we can easily throw that onto other surfaces, stuff like that. If we wanted something that did multiple stuff, because we might then end up having things where it changes stuff like jump height, things like that. This is all now in the one spot, which is really handy for us. So, okay, good so far. What we then want to do is we need the character motor to be picking up on this. So we already looked and we saw we have this ground raycast that's happening. So if we go and take a look for the ground, and we look and see where we're actually doing that, because we'll have our is grounded check. Now this already is doing a raycast, so we already know if it's actually hit something, we know what it has hit as well. So that means we can check if what we have hit has that surface thing on it. So this would be where I would go for an F hit result, and we can't get the game object, but we can go collider, game object, and we can do a try get component. And I want to try and get a surface effect source. And by using try, that means if it fails, which most of the time it's going to, it's a lower cost. It's going to minimize memory allocations, things like that. So surface effect source, which will default to null. And we can just put in here this. So that means that we can then have a surface effect being applied. So what I would do is we want to group this all in a set of functions, so it's all confined to the one area. So what I'm going to do is update or switch surface effect, maybe set surface effect. Source. So we do that. So check for a surface effect. Now, there are other things that we can be checking here, because we can also, if we didn't find something, then we could set that to null. The raycast, if the raycast failed, then we are not grounded, and that means we could also potentially set that to null. Now, this does currently check if there is a jump time remaining, and it doesn't go and update the stuff there, which I think is good, because when we're jumping, we don't necessarily want them to be able to evade being on the surface. So that looks good. So now I'm going to set up down here void, and we'll have surface effect source, new source. Now I'm going to move these variables later, but for now we'll have these set up here. So for now they'll just be here. And what I want to do is I want to check, okay, changing to a new effect. So f new source is not equal to null, and new source is not equal to the current surface source. Then that's changing to a new one. So we're going to just log out. New source. Just log that out. Otherwise, well, we might be on the same one. So f new source is not equal to null, and new source is equal to the current surface source. Then what we're doing is tick source. So we tick that one. We will make sure here we update this. So, okay, one scenario where it's null and it is different, or it's null and it's not null and it's the same. The final scenario we would be able to hit is, it could be the case where if new source is null and the current surface source is not null. So left source. So we left that. So then what I'll do is set the current surface source to null. So this is enough where we can test this. So we're not applying any of the effects, anything like of that yet. We're just testing the bare minimum of, can we actually move and get these messages displaying? And that's really important. Always try and test as early as you can with stuff. So this is something where I can see it's ticking that source. If I leave it, I get a left source. Now that I'm on it, you can see it's continually ticking that up. If I jump, we do briefly get a left source, and we do get changes happening, so that's good. So the jump causing it to leave is something where we want to look into that. So I'm going to just turn on collapse. And that may be with the jump because we're leaving the point where because the jump has the two phases, the up phase and the fall phase. So we are here and we're on the surface. So that does give a left source and then does a re-enter every time. So that's something where what we could check is if we've left it and we are in the middle of a jump, then we could ignore it. So setting the surface effect source, we might be a case where we don't want to allow it to leave if we are still doing the jumping there. So if we take a look at with the jumping side of things, so the jump time remaining, that gets zeroed when it hits the fall point. But we want to check actually if we are in sort of the rise or fall phase. And it may be the case that we don't want to, that we do want to clear it, or that we necessarily don't. We might want to have a bit of lag time, but we do potentially want to, when it goes to leave the source here, check if we are jumping. So in this case, I'm going to log out is jumping, because that will cover whether we're in the rise or the fall phase. And we'll likely see that that actually shows up saying that it's a value of true. Which then detecting that will allow us to, and we can see, yes, it does come up as true. So likely that's something where we might want to do some specific tests or logic there for it. So, okay, in terms of what we do with this. So, okay, we're changing to a new effect. That means we need to potentially update our status of things. So, okay, how this needs to work is going to be an important thing, because these surface effects, it's down to, do these surface effects have a lingering aspect? So is it a case that as soon as you're off of the surface, it stops doing anything? Or is it a case that when you're on the surface, it actually is, having an effect for a bit of a time afterwards? So it does depend upon how we want to actually, work with that. So that's something where how we and where we configure that matters. And we want to think about, okay, where does it make most sense to configure it? And I think this is something where it makes most sense to configure it on this scriptable object for that effect set to essentially be able to have a latency period where it keeps being applicable for a time. Unless, and we could make it that it's unless we switch to another surface. So this is where what I'm going to do is serialize field float, and we'll call this essentially a latency period or a lag time for it of how long it takes to actually sort of carry over. So persistence time. So how long it persists after leaving. So it might say that it persists for half a second. I think in general we'd want these to be fairly low time periods. So, okay, that means when we left a source, we only really count it as left if it's been more than a certain amount of time. So that means we also are going to need to keep track here. So current surface last tick time, which what I will do is that gets set to time.time. And when we leave the source, we actually won't do anything here, because what we'll do is current tick time gets refreshed in both of these cases because we're either on the same source or a new source. And then what I'm going to end up doing is we'll have here void update surface effects. And if the current surface source is 0, it was null, we do nothing. So no surface effect. Now, then, if we do have one, what we want to check is that persistence time. So if the current surface, the last tick time is greater than, and we need to ask that surface for its persistence time. So if we get that, and we'll set this up on the actual source. Let's have a public float. So the persistence time, we can just link that over to linked effect persistence time. So that will be able to just give that back. Now this is where it does get a little bit complicated with some things for being able to actually configure them. So this is something where we would often look at switching these back to public. We could set up further variables, but when it's working with data from a scriptable object, I generally wouldn't. So that looks good. Okay, that last tick time. So we add the persistence time. So if the current surface last tick time plus its persistence time, if that is less than time.time, then expire the surface effect. So time to expire that. If it is, then the current surface source is null, and we just immediately exit. Now, this is something where we have that grounded check is updating in fixed update. The update surface effect, well, we want to work out where is a good place to put this. So the update grounded, I think it's update is grounded, or is grounded. Quite a bit of stuff to the project, so it's a bit. So, okay, this is something where, because that's getting updated here, this is where I would then do the updating of the surface effects, because that way we know it's been refreshed this frame. So the time.time we're referring to is going to be consistent, and these times are going to be consistent. So that should work quite nicely for it clearing it. And again, what I would do is put a debug log left surface. And then we can test that. And that might be just enough with that persistence as well to accommodate for the jumping if it's a short jump. We're on the surface, we don't get debugs for that anymore. We leave it and we do get the message, which is good. I jump, and with jumping, I don't get it. Now, if I jump off of something like that, I do get it, which is good. That's what I want to be seeing happening. So, okay, so far we've got the effects being applied, things like that. So now we need to have these effects actually doing something, because we have that persistence, we have that logic for them. Now the speed for the character. This is something where there's a lot of sort of things we've set up here. Now we do conveniently have stuff where the max speed already goes through a bunch of parameters here. So what I can check is, okay, let's see how current max speed is used. So it does go through the movement vector, things like that. So what that should mean is that down here, I can check and work out a multiplier. So scale factor is going to be if we have a surface effect, or current surface effect, so if that is not equal to null, then I want to be able to do current surface source and affect our speed in some way. So that's going to be how I want to work with this. So I want to be able to put in speed, otherwise we return speed. So it's going to look something like this. So if it's not null, I want to be able to do that, which means I need to pull these speeds into these particular ones. So what I need to do is have speed, which I'll set to 0. And here we set it like that. Otherwise, we set our speed here. So then this, we route it through this value, because then our surface effects source, we give it a public float effect, and give it the current value. And then a similar sort of process, we would do linked effect, current value. So what we're doing is we're putting the logic for performing the effects onto the actual effect set itself. So we'd again have an effect, and we'd have current value. And what we would do is we'll make some changes, and then we'll return that current value. So we'd loop through. So for each, we loop through every one of the effects there. And then that effect entry, well, if that effect entry is applicable, then we would allow it to perform its effect as well. So it would end up being something like current value is entry, effect, current value. But we need to know if it's applicable, because we need to check that parameter type. So what I would do is this is actually going to have effectable parameter. So we just have to pass this all the way through. So it's a little bit of hookup stuff, but once we've got it done, it actually makes it a lot less code for adding things in later. So it means there's a lot of initial threading through, but afterwards it's actually really quite quick for adding things in. So we then say what we're affecting here is speed. So then in our effects set, it can check, well, if entry parameter is not equal to that, because we'll do the not equal check, is going to result in cleaner sort of code. So if it's not applicable, we skip it. If it is applicable, then we're going to run effect, which, similar to what we've done with all of the other ones, we have current value. And then what we do is, again, return current value, but we check our type. So if it's scale, then we could do return current value multiplied by value. If instead it might be offset, then we return current value plus, say we don't need the times equals, we can just do current value plus value. And otherwise, if it's set, then we return value because we're overriding it. So this means we could add in different types of things here as well. You could also add in stuff where you'd have a new effect type that's random, in which case you just add in a single entry here and it's all sorted. So it constrains where we need to make changes if we're expanding this later on, which is really handy. Okay, so this actually should be able to work at this point. We're affecting the maximum speed. So let's find out. What we're hoping to see is that we step on the surface. And I'll be a little careful with stepping on the surface, but I'm hoping, and it does seem like I'm moving a lot faster. If I step onto the ice, move a lot slower. So we've got some simple effects already. So that's great. We've got stuff where we control speed and things like of that. Now, as I said, one of the big values of this is the fact that we can really easily extend and modify this quite readily. So what we could be doing is, if we take a look at now threading this through and adjusting other parameters. So max speed, we already saw where we're using that. So we saw we've got that down here. We could also have stuff where it might then be affecting the camera, because we've got update movement. We could also change stuff there in terms of with the camera. So I believe with the camera stuff, we're doing that in late update. So what I could do is down here, we'll have our inputs. We could mess with those inputs. So it could be something where this surface has more effects than just impacting on speed. It could be something where it also has effects with the camera there as well. We also might want to affect jump height too. So what I'm going to do is in the effects set, let's set up a few more parameters here. So we've got speed. Let's have camera sensitivity. Let's also have jump height. So we've got these additional ones that we will be able to affect. So then adding in those parameters, all we need to do is work out where we hook this up here. So, okay, well, we would be able to say sensitivity scale. If we have a current surface source that's not equal to null, then we would do current surface source effect. And in this case, we are wanting to affect things like our horizontal sensitivity, our vertical sensitivity. So we could change these to H sensitivity, and that uses this particular value. Now we do need to then tell it which parameter we're working with. Otherwise, we just pass in the original value. Now this is where it then gets a little bit messy in terms of the line, in terms of how the code looks. So this is where what I would actually do, so I would change this around a little bit. So what I would end up doing instead is we store these values here. So also have a float V sensitivity on our camera, on our vertical. And then what we could do is F, the current surface source is not equal to null. And then we just do these. And then we're referring to this parameter, so it's a little bit shorter in length. So it just makes it a little bit more readable in terms of with the code. And that's always an important thing. It's the last thing we want is to turn the code into being something that's really difficult to read. So splitting stuff across different lines, stuff like that is always worth doing. So that's good. We've got that is a little bit clearer and easier to work with. So allow surface to affect sensitivity. So that's good. So that's hooked up from that side. And then if we look at the jumping side of things, so if we remember when we are performing a jump, so jump, I don't think we've got a jump requested, but we do have stuff where we set that we're in the rise phase. So that, where we set that to true, which we should only have the one spot, which is the case. So, okay, that's going to trigger the jump, and we've already got a dedicated function for it, which is handy. So if we're in the rise phase, we've got the different stuff for checking if we're hitting the ceiling. And then this is the key bit where it's affecting that jump velocity. Because that's the thing that we would actually go and modify. So again, this is one where, okay, what I would be able to do is, if we write out the line, we'd have our current surface source, affect, config jump velocity, and we need to tell it the jump height there. And I might actually rename that to be jump velocity, to be more accurate, because it is really controlling that speed of it. So, okay, that's good. We're controlling that. Now, the jump time remaining is actually something we could also modify. So we could have it that we don't just modify the jump time, the actual sort of jump speed, but we modify the jump time. So I'm going to set this up. So we have jump velocity, and again we'll do the same process we did with the sensitivity ones, just because that makes it, just keeps the code readable, and that's really important with this. So current surface source is not equal to null. Then we do this where we set jump velocity. So that's good. We're going to do the same thing for the jump time. So again, we could have a surface that makes it that we can jump for a longer period. So what I'll do is float jump time. is our config jump time. We feed this through, make sure we're using that there, and we change this to jump time, and we add that in as a separate parameter. So now we have the ability to affect how fast it jumps, how long that jump goes for, and we can affect those independently. So we could do a surface that is actually sticky, for example, that they move slower on, but they also have less of a jump height for it. So I'm going to make this a sticky surface. So we're updating the speed. I'm going to also say that the jump velocity is halved. The jump time, I'm going to leave it the same, but the camera sensitivity I'll halve. So the jump time can still try and jump for the same amount of time, but it's going to be much lower, much sort of slower. So that looks pretty good. So the speed decrease 1, I'm going to move this over. And this now gets linked over to the sticky surface one. So we'll rename that. So everything should be slowed down on this surface. So we're also going to give it its own material. And we'll make it kind of a swampy sort of green color, I think will be appropriate. It's a bit of a dark sort of swampy color. So now what I should find is, speed up and speed down ones work exactly as we expected. So they're good. And, I can jump the normal height on that one. But I go over to the swamp one and it's slower to move around, it's slower to move, and I don't jump as high. So jump here, jump much higher, here, much less. And I reckon I actually will change it so that it does also reduce the jump time. That might help with that feel of it as well. This thing where it's really easy for us to be able to change these. So we do this. And then now, when I'm over onto this, as well as the camera being slow, the jumping, so it's conveying more that sense of it's really hard to move on it. And this is something where we could have different, you could easily set up stuff for like swamp, different things like of that, to have those different styles. And it's just a scriptable object you update then, and it will update all of the particular ones that you've got. And we're doing this with surfaces, but there'd be no reason we couldn't extend this to have it work for a volume. So you could absolutely have this work for something where it's a volume. The final one I'm going to do, because we've done super sticky, we've done sort of simple speed up and speed down, I am going to make a surface that will be bouncy surface. So again, I'm going to use the sticky one as a base. So bouncy surface. So it's going to increase the speed a little bit, not a huge amount, but a bit. The jump velocity will be increased. Camera sensitivity I don't want to change. Jump time I want to increase. So again, really easy to make these changes. We just set up the scriptable object now, and then give it a new material. So that one, I'm going to make it, I'm going to bright pink color. So that one, when I'm on that one, I should now be able to, the camera will move as normal. My speed is a little bit faster, but my bouncing, I think, is much higher. So my jump there is significantly higher, and it's all just data driven. So it makes it really, really easy to work with this. So you could set up, puzzles, things like of that based upon this, just purely by having these there. Now, if we want to have this carry over for a bit as well, because we want to make sure the carryover works. So what I'm going to do is I'm going to pick one of these, and I'm going to say the bouncy surface. Actually, we might make it the speed increase one. So its persistence time is 0.5. Let's ramp that up to 10. Make it so that it's something that's super visible, so we know for certain that it's working. Because one of the things that's great within Portal is you boost up your speed, and that continues for ages. So there we go, faster speed, and that should, after a bit of time, drop down, and then it's returned back. So the persistence side of things is working, so it means if we want to have an effect carry over for longer, then it can. So that's good, we've got our setup now. We have the ability to have surfaces that affect things. That has happened without much extra cost, because we're already doing the raycast, or the sphere cast in this case. So we're doing one additional check of what that surface is. We're doing that as a try-get component, so that minimizes potential garbage there with sort of memory side of things. It's a bit more of a efficient check in that regard. And if we've got the surface effect, then it can apply. It can linger for a certain time. We made it so that it's really easy to add in different effects, so different things that it affects, and chain together different types of ways that it modifies stuff. And being able to have the one thing affect multiple different items. Now the character is going to be the sort of authoritative source for whether it has a surface effect. So the final thing I want to do is make this, so this is public, but we will make it publicly gettable, but only protected on the set side. That way, if other things needed to query this, they're going to be able to. So the character motor will be the authoritative source for what effects are active and keeping track of that. But now other things can query that if they need to, which is going to be really handy. That means that we've got just that sort of simple central area for it. And with this, as I said, we could easily modify it to be using volumes, things like of that, quite easily. Might be a little bit more expensive because the surface check we get for free. Volume check would be a little bit more involved there because that's an additional thing we'd have to check. But we've got it up and running, and that's the key thing. We've got that infrastructure that we could easily expand. You could have this be doing a lot of other different effects to the player as needed, or affecting other items, stuff like that you want. So this could affect health recovery. So it could affect stamina recovery. It could be that they're in something that drains or restores stamina. All of these would be things that we could easily now do because we've got that infrastructure there of working with the sources. Thanks folks, I hope you found the video interesting and helpful. If you have, chuck in a like and subscribe. It really helps out, it's really appreciated. If you're looking for the code for the project, that code is available up on GitHub, and I've put the link for that in the description below. As with all of the code, you can use this in any of your own projects, commercial, non-commercial ones. It's free for you to be using there. If you've got any questions, chuck in a comment below. And if you're looking for other ways to support the channel, then I do have a Patreon, and there is a link to that in the description below as well. But until next time, bye.